This week we'll begin Chapter 10, which is on hypothesis tests regarding a parameter. These are the slides for Chapter 10, and the slides have quite a few examples and background notes. We'll go right to the lecture notes for Chapter 10. Section 10.1 goes over the language of hypothesis testing. There aren't very many calculations in this section. It's more about concepts and vocabulary. So first, the definition for a hypothesis is that it's a testable statement regarding a characteristic, or in other words, a parameter, of one or more populations. So here's an example. This example is on identifying whether something is a hypothesis. And it says, determine whether the following is a hypothesis, in other words, a testable statement, or not a hypothesis. In 2010, 12% of students at Chaffey College commuted by bus on a regular basis. A transit analyst suspects that the population proportion of Chaffey College students who commute by bus on a regular basis has increased since 2010. The transit analyst's suspicion is a hypothesis. It's a statement about a population parameter. In particular, it's asking about the population proportion of Chaffey College students who commute by bus on a regular basis. More importantly, the statement is testable. To test this statement, the transit analyst could, for example, conduct a survey of students attending Chaffey College this year, use the survey results to estimate the current population proportion of students who commute by bus on a regular basis, and then compare that current population proportion to the 2010 population proportion. Let's look at another example. Example 2 is, again, identifying whether something is a hypothesis. And same thing, determine whether the following is a hypothesis, in other words, a testable statement, or not a hypothesis. A philosopher considers the possibility that the entire universe came into existence last Thursday. All evidence to the contrary, such as cosmic background radiation, radiometric dating, stratigraphy, human memories, all of those also came into existence last Thursday and are merely illusions. The solution is that this philosopher's belief is not a hypothesis. It is not a statement about a population parameter. There's no mention of trying to measure a proportion or a mean or a standard deviation. More importantly, the statement is untestable. If all of the evidence to the contrary are merely illusions, there is no test or study that can be done to possibly refute that belief. So it's a belief, it's an idea, but it's just not a hypothesis in the sense of a scientific or statistical hypothesis. Let's go deeper. When doing a study and conducting a hypothesis test, you could think of that study and hypothesis test as being made up of 3 main steps. Of course, there are other steps that you would probably take, but this kind of breaks it down into the basic steps. The first step is that you would make your hypothesis, and that hypothesis would be based on your own knowledge as an expert and also your knowledge of previous studies on a topic. The second step you would then do is to collect the evidence, do your calculations, and then use that evidence to test your hypothesis. And then the third step is to analyze your data and use probability to assess whether that evidence supports your hypothesis or not. hypothesis statements are composed of two parts. One part of a hypothesis statement is the null hypothesis. And the null hypothesis is symbolized with this H sub 0. The null hypothesis is a statement that there is no change, or no effect, or no difference, or just the status quo. It's the hypothesis that there's nothing unusual, nothing has happened differently in this situation. And it's assumed to be true until your evidence indicates otherwise. The second part to a hypothesis statement is the alternative hypothesis. It's symbolized with either an H sub 1 or an H sub A. In our book, they use H sub 1. And the alternative hypothesis is a statement involving a difference or a change or some departure from the status quo. Usually it's the statement that you as a researcher are trying to investigate. Either you're trying to find evidence that supports it or that does not support it. When you make hypothesis statements, there are a few different kinds of hypothesis statements that can be made. One kind of hypothesis statement is called a two-tailed test. And a two-tailed test is one that involves a not equal to symbol for your alternative hypothesis. It's called a two-tailed test because the hypothesis test involves both tails of a distribution curve. Another kind of hypothesis is a left-tailed test. Left-tailed tests involve alternative hypotheses with a less than symbol. And they're called left-tailed tests because they involve the left tail of a distribution curve. A third kind of hypothesis is the right-tailed test. Right-tailed tests involve a greater than symbol for your alternative hypothesis. And the test involves the right tail of a distribution curve. Up to this point, we've talked about many abstract ideas. We'll take a look at some examples that put these ideas into context. So example 3 is looking at null and alternative hypotheses. This is similar to 10.1 numbers 15 to 19 in the textbook. And the instructions are to determine the null and alternative hypotheses for this situation. The situation is the same one that was referred to in the previous example. In 2010, 12% of students at Chaffey College commuted by bus on a regular basis. A transit analyst suspects that the population proportion of Chaffey College students who commute by bus on a regular basis has increased since 2010. To determine the null and alternative hypotheses, the first thing that you'll want to do is to ask, what parameter does this situation refer to? Is it referring to proportions or means or standard deviations? And based on that, what symbol should we use? Well, this problem is referring to population proportions. For that, we'll use the symbol P. Let's define what P actually will represent. P is going to represent the unknown in the problem. What is known is the proportion in 2010. So there's no need to give a symbol for that. We know it's 12%. But what's unknown is the proportion today. The question is, has it increased since 2010? In other words, is the proportion today more than what it was in 2010? And P is going to represent that unknown. So P is going to represent the current or this year's population proportion of Chaffey College students who commute by bus on a regular basis. Now that we've defined P, we can identify the null and alternative hypotheses. The null hypothesis is that this year's, or the current population proportion of Chaffey College students who commute by bus on a regular basis, so P, is the same as the 2010 proportion of Chaffey College students who commuted by bus on a regular basis. The null hypothesis is always that there has been no change, and this is what it's saying, is that this year's proportion is just the same as the 2010 proportion. The alternative hypothesis is the hypothesis put forward by the researcher. Back up here, the researcher was suspecting that the proportion has increased since 2010. So the alternative hypothesis is that this year's population proportion who commute by bus on a regular basis is greater than the 2010 proportion. Those are the null and alternative hypotheses, but they're long sentences, and it takes a while to read them and convey what they mean. Usually when you write hypotheses, you'll write them using symbol. We'll start with the null hypothesis, which we'll write as H0, and we'll just put a colon. The null hypothesis is that the proportion today, which is P, is just the same as what it was in 2010, which was 12%, or 0.12. The alternative hypothesis, which we'll symbolize as H1, so we'll put H1 colon, is that the proportion today is greater than the proportion in 2010. We could write that as the proportion today, P, is greater than the proportion in 2010, which was 12%. Right below that, I've written the symbols typed out, so it's easier to read. If the alternative hypothesis proposes that something has increased or is greater, then the hypothesis test will be based on the right tail of the distribution curve. In other words, it will be a right tail test. And in this case, the greater than symbol is used. This would be an example of a right tail test.